And then we discussed the flat file database system. And in the flat file database system, I discussed with you that this is the area where you have no you where you have duplication of data. That the term that is going to refer to as duplication of data is known as data redundancy. And data redundancy means that if your data is being duplicated. So in a flat file based system, you can have problems like inconsistent data, data being dependent on other fields, or if you have limited access. The solution of that is basically an example of a relational database. Like for example, you can see right here that there are three tables that are connected with each other. I have people, I have class, I have teachers. The people's ID, first name, last name, current grade, class ID. You can see that class ID is one of the field that is connected in your class. And when it goes into your class ID, class name, teacher ID, room number, then this teacher ID is connected into the teacher table. So what I want to make you understand right here is that one field from each of the table is being connected with the other table. So that basically means that the relationship is many to one relation. Like you can see that there are many peoples, but class is one. There are many classes, but teachers is one. So this is the area where we call it as a relational database. A relational database is one that separates the logical structure of data from the physical structure. This basically means that all of them are connected with each other. Whereas when it comes to a flat file system, your data is not connected with each other. And this is the reason that you might have inconsistent data, you might have dependent data, or you might have inaccurate data, or repeated data. Like for example, if you have a repeated data right here, it cannot be possible because all of the data is quite connected with each other. The data is synchronized with each other. But when you work with a flat file system, it is not connected. So there are chances unto that. For addressing your data inconsistency, you can say that because data about an entity is basically stored in one location and therefore only has to be updated in one location. This reduces the probability of your data inconsistency. But just in case if you have data stored in many places, and if you are changing a data at one place and you have a flat file system, that would mean that you have to change the data in all of those places, because that is a flat file based system. And when it comes to a flat file based system, that means that the data is uh, uh, the data is connected. That is in a relational database. So if you change at one place in relational database, all of the data changes. But in a flat file based system, you need to change the data individually. That's how you can address data inconsistency, even the data redundancy as well. Redundancy basically means regarding the duplication of the data, because each type of entity is stored in each table. Data dependence is like, for example, some fields are dependent on others. Like, for example, I have a first name, I have a second name. For example, my name is Sir Wamiq Akram. So my father name is connected with my name. So this is how the data is dependent. For example, if you are studying A levels IT, your class is dependent. Like this was an example of an old format of data that was difficult, but if you can see right here, this is your data dependency. Right now, we are not discussing SQL, so just leave it. I just want to also explain you the things as well that are right here. Now, I want you to understand that, for example, if this is a table, so you can see that in this table, you are being given like the name, the age, the telephone, the email address. You have four fields like this. So these names are to be known as an entity. An entity is a type of thing that is being represented into a separate table. Like all of this is representing a different entity, and each column is known as a field or attribute. This is a field or attribute. This is basically a field or attribute as well. Similarly, on the left hand side, each row in the table holds one record. So you can even call it a record. You can even call it an entry, the whole of it, like bill, age 22, telephone, email. This is an example of a record, or a tuple as well. Tuple is also named, which contains data relating to one particular instance of an entity. You need to understand that the entity is name, age, telephone, email address, and their record is the one. Do you have any confusions in this terminology, like this table, relation, record, tuple, entry, field, attribute?
No, sir.
Is it clear?
Yeah.
Okay, so if I move on, we will be also be having tuples as well. So tuples is basically like each individual entry in a table, like this. The arrow shows you like bill. So this is an example of a tuple which shows a single entity which is being stored as a record. So you might think of record as an individual row in a table, or each record contains a number of fields. So for example, if I'm looking forward this bill record, so what are the number of fields? It's bill, age, telephone, and email address. The whole of it horizontally is going to be known as a record. Then we need to discuss the primary key, candidate key, and secondary key. Primary key is, we have already done. Primary key is basically a unique value that identifies each row or each record in a column, and any column in a database that contains a unique value, and data and non-nullable data is a candidate key for being used as a primary key. I will explain this candidate key further. We have also discussed foreign key as well. Foreign key is basically, I have given you the example of that as well. That is basically a primary key from another table. But the thing is that it is used to connect the two tables together to form a relationship. It is a primary key, but it is connecting. Like for example, you can see that if I have a table named person, and in a person I have employee ID, name, address, and passport ID, but passport ID is also referring to the other table as well. Okay, now so far what I have discussed with you already is this database structure, the uses of that, creating a database, flat file, record, entity, attribute, fields, primary key, software, recap is also done. Relationships, data types, and field sizes are also done. Relationships, we have discussed this. Foreign key, we have discussed quite in detail. We have also discussed the relationships as well. The relationship is one to one, one to many, and many to many. Let me give you a recap of this, all of these relations, so we can continue with that. Now, like this is right in front of you is an example of the one to one relationship. A one to one relationship is where two tables are connected with one entity connecting to one other entity in the other table. Like for example, if I have two tables, if this is the person table that states your employee ID, name, address, and passport ID, but that passport ID is connecting to another table which has its passport ID, first name, and last name. That is not included in the first table. So this is the relation where you are matching one table to another, or you can say one individual to another, or one entity to another. That means that I am not referring to many entities or many things at once. So this is an example of a one-to-one relation. Any confusions in this?
No, sir.
Then when it comes to a one-to-many relation, this is basically where two tables are connected with one entity. Two tables are being connected with one entity, connecting possibly too many other entities in other table. Like for example, you can see on the left hand side, you have the teacher table. Teacher table has a teacher ID, it has a name, it has an address, but a single teacher can have many classes. So you can see that a single teacher can have many classes, and here you have it's written like the class ID of that, the class name, the location, and the teacher ID. So basically, this teacher ID is basically common in both of the tables, and I can say that both of them are quite connecting with each other. So this is referring to one-to-many relation, and the field that is connecting the both of them, or that is common in both of the tables, is the teacher ID. That means that if a teacher ID is something like 66097, so there can be all of the data for all of the classes. The point is that the teacher is one, the ID is one, but the classes are many. So this is the place where we say that this is a one-to-many relation where two tables are connected with one entity connecting possibly too many other entities in a table. Now, you also need to focus on one thing is that how they are being connected. I'll also show you the diagrams as well. Just after that, there is also an example of many-to-many tables where two tables are connected with many possibilities. So as far as these three relationships are concerned, the first one is a one-to-one. A one-to-one relation is when each record in one table only connects to one value. I have one-to-many and I have many-to-many. I hope that it's clear. Now, moving on to the next thing, that how can we create and use these relationships? So when creating a one-to-many relationship, there are some rules that you need to follow. The first thing is that in your one-to-many relationship, the table on one side must have a primary value. It means that it should must be having a unique value. The table on the many sides will have a foreign key. The data type and the field size of the foreign key must match the primary key on one side. Only data item that exists in the primary key on one side can be used in the foreign key. So let me give you this example, and let me try to illustrate you the rules for a one-to-one relationship. Like right in front of you is a one-to-one relation. So if I check the first table, the first rule, it says that, wait, yes. It says that the table on one side must have a primary value. So we must be checking that the table on the one side must be having a primary value, and that is a passport ID right here. The second rule, it says that the table on the many side will have a foreign key. So most importantly, these rules are not like that. All of them have to be matched. Like even if the one of the rule is being followed or it makes sense, you are good to go. When it comes to a one-to-one relation, at least one of the table A must have a primary key. The other table must either have a primary key. So you can just read it out yourself as well. One thing I need to discuss right here is regarding your normal form. The problem with many-to-many relations is that it is not possible to store single data items within the foreign key. Like within the foreign key, you cannot store a single data items because foreign key is itself being connected to two of the tables. Like they like in the order and product example, the product ID field contains more than one product ID per order. So this may creates a problem for a non-atomic data that breaks the rule of 1NF. So we are actually going to understand this 1NF, 2NF, 3NF later into this chapter. But I just want to confirm you regarding the category of the database that first of all, it is going to be considered as a normal form. A normal form basically means that the extent to which a database has been normalized. So whenever you will be creating the databases in MS Access, so we will be normalizing that as well. Like if it is a relation 1NF, 2NF, or 3NF that we are going to discuss. Now, we need to move on to this entity diagrams, ER diagrams. But okay, so first of all, I also need to discuss with you that how can you create a one-to-one relationship when it comes to a table. So if it is a one-to-one relation, you can create tables. Like for example, this is a sales representative and this is an employee table. So if you want to show a one-to-one relationship, you can create a diagram like this, but the only difference is between the lines. Like if this is a table and you want to show it as a one-to-one, so you are going to add a bar right here, a line right here, and a line right here. So this basically means that this is a one-to-one relation. Similarly, if you have one to many relation, how you are going to show this is regarding the category and regarding the product. Boxes are going to be same, but you are going to create it like this. The one sign is going to be same, that is right here, but this is basically a many sign. That means that a single category can have many products. This shows you that it has many products. This is your first category, this is your second category, and then for your many to many relation, like for example, if you have many orders and for example, if you have many products, this is going to be simple many to many. We are going to use a symbol of many. So again, I have the two tables right here. and like this. So this is an example of a many to many. So these are some diagrams that you need to keep in mind. Diagrams for your relationships. And just after this, we need to discuss regarding entity diagram. Like what is an entity relationship diagram, which is to be known as an ERD. I have already explained you that how can you create them, but let me give you let me teach you the theory part for that. So basically, what is an ERD diagram? An ERD diagram, entity relationship diagram, shows the relationship, shows the relationship connections between each entity. ERD diagram is basically, you can say that a diagram that represents the relationship between entities. And you know it already that what do you understand by an entity. So when it comes to an ERD diagram, you have three types of an ERD diagram. The first one is the physical one. And the physical one is the one that basically describes you the structure of data that is or will be used within a relational database. You need to understand the two words that I am teaching you right here. That is a relational database and a flat file database. Both of them are different. I have explained this earlier into my lecture. The physical diagram states that the structure of data that is being used or will be used within a relational database. That means that all of the databases are being connected. That meets both business and data needs. So this is the first category, and you know the purpose of that. The second category I have right here is going to be your conceptual. You can stop me anytime if you have any queries, and you can also go back through my lecture. I will upload this as well. So the conceptual one is basically like if you are using during the analysis of that analysis stage of your system life cycle. A conceptual one is like theoretical, or for example, if you are creating a concept of something, or example, you are giving the concept of that during the analysis stage. Like for example, if you are in a business and you have created a database or a table, and now you want to visualize that. So in your visualization stage, like I can say you are making an analysis. So this is where it comes into use, that the conceptual one is used during the analysis stage of your system life cycle. System life cycle is basically a life cycle that we are going to discuss later. That is in a different chapter, but I'm just teaching you that this is implemented when you are creating a piece of software. It shows the relationship between existing entities. within a business and attributes. And the third layer, which I have right here, is going to be your logical layer. First of all, this is an extension, which means an extended version of the conceptual layer, and this also includes the data types as well that we have discussed earlier. The logical layer is only used for the analysis purpose. So this is it. I have explained you both of the three categories, and I have also taught you that how can you create them by giving you an example of that. The next thing that we have to discuss is okay. So just after my class, you can complete this activity 10.6. You can tell me the relationships of that. After this, it says that we have different relational database softwares and different symbols. For example, we will be using Microsoft Access that uses the infinity symbol for many sides of relationships. Like for example, if you have more number of relationships, so you can use an infinity symbol. Other softwares may use a different example. You can go through that. These are okay. So these are some of the alternative symbols as well. You can go through it on your own. Page number 195. Page number 196. The difference between a flat file and a relational database. I have covered it already. A flat file database that consists of a single table. It has no relationships. It is like looking all the data in a single spreadsheet. It is called flat because it has only flat data. Like this example, data redundancy we have done, flat file we have done. You need to go through that relational database. I have also explained you through this into my PowerPoint. Okay, so I basically want you to go it through till page number 199. And you need to report back to me into the